All right, good afternoon, everybody. I think we'll wait for a few more minutes just for the others to join us, and we can start on the talk today. The title is going to be on machine learning concepts and applications. I think maybe the invitation which you have received, it was saying artificial intelligence, but it's the same topic. We are not changing the topic. It's just to be more specific in terms of what we're going to talk about today. So the this session is going to be recorded, or it's already been recorded. So if you have any objections to being recorded, or if you want to say something which you don't want to be on the recording, please let us know. Otherwise, the recording will be available later on for people to look at it. And I think it's going to be deposited on the group website or the center website, or repository of the center. So let me start by saying hello to everybody and thank you for joining me on this talk. I'll try to keep it within the hour, and hopefully we can look at some of the concepts and the applications of the artificial intelligence systems. By all means, by the end of the talk, we're not going to be an expert in artificial intelligence as it happened, because the field is very large and it's very big and it's being developed every day. There are new inventions or new methods which have been developed. So I'm going to give just a light touch on the machine learning algorithms that are available, and the famous ones, of course, not everything we're going to talk about, and some of the applications which might be something helpful to some of the audience who can benefit from using AI techniques in the field, depending on what they are doing. So an outline for the talk is going to be about the artificial intelligence and machine learning. And nowadays, the artificial intelligence terms is being known very widely by lots of people in the industry, and then of course in the universities, and then even in the news, everybody talking about AI, and barely you can hear about machine learning. Everything is an AI, and then AI, as it happened, it's a very large topic, and then there are lots of things that happened in the past that it wasn't known as AI, but despite that, it was an AI type of application that we were not aware of at the time, until recently, when this term, which is the artificial intelligence, became very popular, and then people started using that as a term which is known to everybody. The next, we're going to talk about some history of when it was developed and how it became to be known as AI nowadays. And we will talk about how the machine can learn although it's a topic that, again, it's a very big topic, but usually it's an algorithm that the people use in order to make the machine learn from data as it happens. So there are two types of machine learning, which is the supervised learning and the unsupervised learning. These are the first two types of machine learning algorithms that have been developed in the past. And depending on the application that you are using and the data which you have available, you can use one of these algorithms in order to generate a sort of a model that you can use for predicting the behavior of your system. And recently, and that happens recently in the last 10 years or so, deep learning came to be known as well, which is very associated with the term artificial intelligence. So deep learning is the step that, or let me call it as the leap that happened in the field of the artificial intelligence, which makes it very popular, and everybody is talking about artificial intelligence. And then you can hear lots of people on the news or organizations, whenever they have a problem, they say we're going to use artificial intelligence to solve it. It does work, of course. However, there are limitations to that one. You cannot just use it for anything, or you cannot use it for something that is working. For example, if you have a very precise model, a mathematical model of a certain system, why do you want to use artificial intelligence to model it if you have the gold standard, which is the original system that you want to use, instead of going and start applying artificial intelligence algorithm to generate a model that going to do the same thing for you. We're going to talk about some applications as well, which is what people are using artificial intelligence for. And I'm going to touch on the future as well, and what the future will be holding as well for us in terms of using these machine learning algorithms that could be something that is beneficial in the future, or you might end up with cyborgs that can basically start a war against the humanity, which is a possibility. You never know what happens in the future. So this is why it's important now to regulate things rather than leave it until the end. So in this slide here, which is the artificial intelligence, and you can see that there are different areas as it happens, which you can classify the artificial intelligence on machine learning and deep learning. So the artificial intelligence is basically the big umbrella as it happens, which consists of all the algorithms, which are basically, it's any technique or algorithm that enable the machine to mimic a human intelligence. What it means by human intelligence is basically to think the way we think as humans. And one of the particular things that we have there is the machine learning. So not all the algorithms that are under the artificial intelligence, they can learn. Some of them they cannot learn. Basically, they can just process data and generate a model out of it, but it's not really learning, although nowadays most of the people think everything is learning. But some of it is basically purely mathematical based, like linear regression. But again, they say machine learning, which is, I don't really agree with most of these terms in terms of how you can define things. So the machine learning, basically, it's a statistical method that enables the machine to learn from data. So basically, without data, you cannot make the machine learn. It's like us humans, when we start learning something, basically we learn from examples, and these examples are really embedded within the data that we're going to present to the machine in order to learn from them. And the deep learning is a very specific field that people are using nowadays to develop what we call it as a neural network. And I believe most of you have heard of the term neural networks, which is basically an algorithm that mimics behavior of a system. And the way it mimics that behavior is going to extract a knowledge from the data that it will be provided to it. And it will start to organize itself inside the network itself. And based on that network organization, which is within the network itself, it's going to mimic or it's going to model a behavior of a system. As you can see here, that the flops, which is the floating operation point per second, or that's basically the processing power of the microprocessors or a computer. You can see in the 50s it was in thousands, now in the 80s in millions, and then Looking at the future, it's going to be quadruple, basically quadrillions, which are going to have a lot of processing power, which is basically going to help us in terms of processing these data. And machine learning, which is the deep learning, it happens after 2015, and that's basically when we have the big computers, or the GPUs, as it happened, what they call them, GPUs, which are the graphical processing unit, which are very fast in terms of processing data, and that's what made the field to leap in terms of the development because of the processing power. If I want to process a deep learning algorithm back in the 50s, I think it's going to take years rather than days in order to process these type of information. But it's only because of the development in the processing power that we have nowadays. We can progress and develop these type of algorithms that are very complicated and very powerful as well in the meantime. So how to define a machine learning? Basically, we want to teach the computer the way we think. And basically, a human, when they think in a natural way, human or animals. And basically, they learn from experience. So, for example, when a child starts to learn how to walk, they will start by learning step by step. So they will start to crawl first, and then they will start to stand up, and then they will take a few steps until they become very expert in terms of walking. And even sometimes if they go and do more physical exercises and physical training, they will perform even better than normal humans, which are basically, these are the athletes which have good capabilities of achieving records. Now, the machine learning does the same thing exactly. So it will start from a very basic crude model of the data, and it will start to improve these models step by step. And this is what we call it as iterative learning. And you learn by iteration. So each iteration you learn a bit, and you improve things until eventually you come to the point when the system becomes, I wouldn't say perfect, I would say the system will become able to model the behavior that you're after. Usually these algorithms are used for modeling phenomena that are not easily to model using mathematical equations. And I did mention that earlier, that why bother modeling a system using a neural network or machine learning if you have the mathematical model, and the mathematical model gives you the exact behavior or the exact physical changes that you expecting from the system. Although, well, nowadays I think lots of researchers, they do that. It's not for the purpose of generating a new model. It's for the purpose of testing the model rather than seeing the developing a similar model that is already existed. And that's how people develop new algorithms. So if you know the gold standard, you can develop a model or a system that basically mimic the behavior of that model exactly, and you can eventually take it to a different process that is not easy to model. So learning from data, usually it's the way most of the machine learning algorithms work. So you need to present them with data, and data, they have to have some features inside them. And then the machine will extract features from these data. And these features will basically modeled inside the algorithm itself. And then eventually, when you start presenting new conditions or a new situation which the system hasn't experienced, the model can predict for you behaviors that you don't know about or you haven't experienced before. And this is the beauty of these type of algorithms. So basically what you do, you start training a system, and the system will learn from the data. So when you present it with a new situation that hasn't seen before, it will be able to predict these situations for you, even there is no data which you had trained on the situation that you are testing. And there are lots of applications that basically used in machine learning, like decision-making, medical diagnosis, stock trading, energy load forecasting, and other application that is being applied nowadays. Even nowadays, people are using machine learning or artificial intelligence to generate or mimic people talking. For example, I think you can see lots of characters who are really, they don't say what they are saying, but it's basically all generated by the machine. And that's basically, they learned, the machine learned how the person behaves, and then they started mimicking his behavior eventually. So with the data applications, there are lots of applications. For example, we can look at these. I think most of you have heard of the term big data as well. Big data is a term of which has been introduced recently, and lots of people are using this term because it's a new term that basically processes lots of data. And that's what we have nowadays, because we have lots of systems that generates data. And all these data basically are being fed into the machine, and the machine can learn from these data. So let's look at some of the real-world applications. The computational finance, credit scoring, even they use it for trading nowadays as well. Other applications like image processing, computer vision, face recognition, and we've seen lots of debate on the face recognition cameras that are available around lots of cities nowadays, and then they are thinking whether that's legal or basically intruding the people's privacy and whatever. So lots of algorithms are all based on machine learning nowadays, which are basically used for face recognition, motion detection, and so forth. Even in biology, lots of people have worked on the field, and then they are using it for diagnosis of cancers or drug discovery or DNA sequencing and so forth. Although it's not only limited to that, we can go to energy production as well. And people are using that for forecasting the load on the grid. And then basically based on that one, they can predict how much energy to generate within the forthcoming week or maybe day, depending on the conditions around. In addition to that one, automotive or aerospace, manufacturing, lots of application that has been developed using machine learning or artificial intelligence. Natural language processing, and then you can see nowadays we can talk to our phones easily without any problems, and then you can have people with different accents, with different dialects. All of them, they can talk to the phone, and the phone that can understand them. And this is one of the things that have been developed. This was one of the big challenges for the software engineers in the 80s and the 90s in order to make the machine understand the people, how they talk. And I think you can experience that if you have a car which has voice recognition. It doesn't always recognize what you say. However, your iPhone or your Samsung phone, they always recognize what you're saying, because they have much more advanced algorithm that they have used inside their hardware in order to make it easily understand what we are saying. So this is one of the challenges that we have used nowadays with the machine learning. Although if you think of Siri, or if you think of these phones in the past, they were all having these features, and that was maybe about 10 years ago or so, but it wasn't known as artificial intelligence. These algorithms, they existed before. However, people, they didn't recognize them as AI. Basically, they say this is a natural processing algorithm or whatever. But nowadays, everything they were talking about AI, and they being marketed as an AI algorithms nowadays. So this is the main difference nowadays before knowing the term, and then when we know the term. So this is some history of the machine learning. So you can see the field has started in the early 50s. And these are some of the algorithms or some of the applications that has been developed at the time. Remember, this is 1950s. Computers, they didn't exist at the time. The computers were mostly analog computers, if you think of them, op-amps, and then integrators, differentiators, gains, and whatever. But these theories, they existed at that time, although they were not implementable because they didn't have computers. However, they do exist. And if you think of a neural network, you can see it's invented in the 60s, and that was a long, long time ago. And computers, they didn't exist apart from maybe the Apollo mission, which has been later on been flown to the moon. And then it was one of these powerful microprocessor at the time, which is nowadays you think of it, it's you think this is a very simple microcontroller or microprocessor. Again, you can look at other applications like pattern recognition, limit theory, and then the Minsky probe limitation of perceptron. And this is one of the drawbacks of the neural network at the time. So they presented a problem which is known as the XOR problem, which is it's a logic gate, and it's an XOR gate. They introduced this problem to the neural network at the time in the 60s and couldn't solve it. And that was one of the drawbacks of the neural network at the time, and then they stopped using them eventually. But however, later on, I think people started working on them and they developed them further. So you can see in the 70s, symbolic concept, arch learner, expert systems. And this is one of the good things that happened at the time, expert systems. It was very famous in the 70s. Lots of people used it. Lots of companies developed algorithms for that one. And then it was successful at the time. However, it was superseded by other algorithms afterwards. So you can see lots of applications here. And if we move to the 80s, and that's basically when the computers become more available to people, and then people started to have their own personal computers, although they were very expensive. It was, I don't know, it was 8086 and 8080, and then there was, you buy a computer with a very big hard disk, and it was basically 40 megabyte, and that will say, ooh, that's a very huge hard disk. And so at that time, you can see lots of algorithms have been developed as well. And I wouldn't go through all of these in details, but you can see the concept is being developed through time. And in the 90s, when the computer become more powerful, so you can see data mining, adaptive software agent, text learning, reinforcement learning, all of these become available. You can see here more algorithms are more complicated, like the ensemble, the bagging, the boosting, Bayes network. All of these became available to people to use. And then, of course, in the early century, which is 2000, more developed algorithms like the support vector machine, transfer learning, which is, I think there are lots of people use it nowadays with the deep learning. Even people use it for email management, for robotics, for vision. So you can see lots of development happened in the century, beginning of the century. And then in the 2010s, and that's when we come to the deep learning. So if you remember that, I think most of the features on these phones, they were available in the early 2000s. The phones can recognize your voice, they can look at your image, they can recognize your image and so forth. However, it wasn't known as artificial intelligence. Only in the 2010s, then they became known as artificial intelligence, and people use the deep learning system, the big data, the Bayesian network, and so forth. So these are the mostly the new application that people are using nowadays. Now, how do the machine learn? So there are, I've mentioned that there are two types, which is the supervised and the unsupervised. And the main difference between them, that the supervised, basically, it's a system that learn from data inputs and outputs as well. So you know the relationship between the inputs and the outputs. And so, for example, if you have a system that you presented with inputs and produced an output, a certain behavior, you can use what we call it as supervised learning. So the learning, basically, it's being supervised by looking at your prediction from your system, and then the actual output from the data that you are learning. And based on that, they try to adjust the network such that it's going to mimic the behavior of the system. So one of these applications is regression, which is basically to predict the behavior of a system, or classification, which is another application that people can use in order to classify things in different groups as it happens. However, the unsupervised learning, it's a bit different in terms of what you're presenting to the system. So we're only presenting to the system the input side of the data. We don't present the output side of the data. If you don't have it to start with, for example, we are looking at maybe behavior of people who are shopping. So what they buy, frequency of buying, and what type of product they buy. All of these, they can be used as an unsupervised learning, because you can have these people clustered into groups, and then you can target them in terms of what type of shopping that they are doing. So basically, you start bombarding them with the adverts related to their interest. And that's basically what most of the search engines nowadays they use. So I think sometimes when you type a word in Google, the next day or maybe the next minute or the next hour, you'll have adverts related to what you have searched for. And even sometimes nowadays, I think when you say a word, especially if you are talking to your friends and then you say a word, basically a keyword, the phone or the computer will pick that word up and then it will start searching for things related to that word. So I think most of the companies are using that, and Google, I think, is one of the companies that are very interested in these type of marketing schemes. And usually when you sign up with Google, you're giving all your rights up to them, so they can do anything with your data as it happens. And this is something which we usually don't care about when we sign up for Google account. Agree? Yes, I do agree. And then you are more interested in creating the account rather than knowing what your rights are. And usually when you sign that for that account, it's a free account. However, you are giving up your rights, by the way. And this is something which most of the people, they don't care about, but of course they can use it for marketing. So the supervised learning, as I have mentioned before, it's basically built a model based on the relationship between data, input, and outputs. So for example, if I want to model a system that, for example, a production system that you feed materials to it, and then you can produce an output from that system. For example, you are weaving a certain type of fabric. You want to look at the quality of the fabric. So you feed the type of raw materials, and then you get eventually the fabric output. So depending on the manufacturing process, different parameters, depending on these, eventually you're going to end up with the type of the fabric quality. And this is how we can model that system, by mimicking the behavior between the input settings and the output as it happened, in order to try to get the behavior. And then once you get that model, you can play with the model and then try changing things in order to improve the quality of your product. So supervised learning, it can also be used for classification, as we have mentioned before, and regression, which is basically to predict what's going to happen to the features of the output of your product if you change things on the input. So the classification, it depends on, for example, if we think of biomedical applications like cancers, you can look at the patient input parameters like the age, the behavior of the patient, smoking or not smoking, the type of food, and so forth. And based on that one, you can predict that the patient will have, God forbid, this type of cancer in the future and so. And basically, that's more like classification. However, a regression model, it's a bit different in terms of what you use it for. So, for example, if we are producing materials depending on the temperature and the fluctuation of power, you can predict the electricity load based on the inputs here, which are basically more like a continuous prediction of the output depending on the input parameters. So it's not classification, it's more to do with continuous prediction. The unsupervised learning, as I have mentioned before, it's a bit different. So we are not looking at the output of the system. We are looking at the behavior of the inputs of the system. So, for example, people are shopping for clothes, what type of clothes they shop, whether it's expensive or not, how much they spend, and when they spend it, which day of the week, and all of these behaviors of people, we can basically use them into the machine learning. And then the machine learning can classify these groups of people into clusters. And then you can know that these people are interested in expensive products. They are more interested into buying in the weekend, more likely, maybe not during the day, and so forth. So based on these, the companies are basically targeting them in terms of the adverts. So they know where to send them the adverts and how to send them the adverts and what about as well. Even they send them sometimes offer and so forth. So it's more to do with marketing as it happened there. And this is all based on the machine learning as it happened, as you can see it here. So which way should I use? Should I go for supervised, unsupervised, for clustering, for regression, or whatever type of model that we can use? It all depends on the data that you have. It all depends on your problem. So there is no one solution fits all. It's always dependent on the type of the problem that you're dealing with. As I have mentioned earlier, most of the people nowadays, they say, okay, let's use machine learning, we can solve the problem. But there are more to it than just the term machine learning. You need to understand your system to start with, and you need to understand what type of data that you have. And of course, you need to know how to model it and so forth. And of course, depending on your data as well. So you need data which has varieties in it in terms of the input parameters, not fixed. I can model a system with a fixed input, but that wouldn't basically predict anything for me if the input changes, because I only train the system for certain type of data. We've mentioned that the supervised, and depending on the type of the supervised, there is a classification. So these are the algorithms which are available nowadays, and I think most of you can use them nowadays. I think most of these algorithms are available as codes which people can use. MATLAB has got of these built into the system, which you can use them easily. So if somebody wants to do some supervised learning for a classification problem, these are the type of the algorithms, like support vector machine, discriminant analysis, naive Bayes, and nearest neighbor. There are others as well, so I'm not mentioning everything here. On the other hand, there is the supervised learning, but it's used for regression. So basically, we are predicting continuous output rather than classes. So some of these algorithms, like the linear regression, which is basically very simple algorithm. The support vector regression, that's another one. There are some of what they call them ensembled methods, and that's basically to improve the prediction accuracy or the model accuracy. Decision trees again, and then of course the famous network, which is the neural network, and then lots of people are using neural networks as it happens nowadays. So the neural network, we did see in the previous slides that was invented in the 1950s or 60s, and then it wasn't very successful in solving some sort of problems. But if you think of it, the neural network is the base of the deep learning algorithm. That's how they came out with the deep learning afterwards, which is it's a neural network, but it's a more advanced type of a neural network. On the other hand, the unsupervised learning, which are basically mostly used for clustering. So there are algorithms like the k-mean, the fuzzy c-means, some hierarchical clustering, Gaussian mixture. Even in neural network, there are types of neural networks that are used in the unsupervised learning method. So neural network is not always supervised. Neural network could be used for a classification as supervised learning. It could be used for regression as supervised learning. And there are certain types of neural networks, like using the unsupervised learning and used for clustering. It's all type of neural network, like Hopfield and then the self-organizing map. These are type of algorithms which people have used in the past as unsupervised learning. And nowadays, when you think of the deep learning, it's a combination of all of these. So what they have done eventually, they shoved all the type of algorithms for learning together into a single neural network, what they call the deep learning. That's why it's very, the term which comes as deep learning. Of course, the hidden Markov models is another application or another tool that you can use for clustering. So which one should I use? This is something that you have to think of at the first step in order to understand what type of algorithm you need to use in order for your application to be successful. So you have to consider what type of problem that you have to start with, and the size of the problem as well. So I wouldn't go and use deep learning for a simple problem, which I can model using a simple neural network. It will be a waste of resources and a waste of computation time. However, if you have a complex problem, of course, you're going to need to have the deep learning. So some of the applications here, like handwritten recognition, face recognition, speech recognition, all of these are more advanced type of application that you need to use very complicated algorithms. However, lots of algorithms are being invented. So nowadays there is the long-term, short-term memory, there is the recurrent neural network, there is the YOLO, which is it's another type of neural network that people have used now. It says you only look once, and there is the extreme learning machine as well, which is another algorithm that people have developed. So things are changing all the time, and depending on the application, you need to know which algorithm is the best to use. Some typical applications for supervised learning. This is basically to predict the or diagnose the heart rhythm. So in the old days, I think the doctor they used to look at the response of the heart when they take the recording from the heart, and based on that one, they look at the troughs and the peaks, and they look at the behavior of these signals in order to diagnose what type of problem that the patient has. Nowadays, of course, these data could be fed to the machine learning algorithm, and then the machine learning algorithm can be used directly in order to diagnose what type of problems. However, there is an issue here which we have to think of, is how can we trust this machine? Whether can I trust this machine to diagnose my problem in terms of whatever medical problem that people have? This is something which is, again, it takes long time to approve, and lots of ethical approval needed to be done before doing so. However, now most of the time they use it as an advisor rather than as a decision maker. So at the end of the day, the doctors still have the upper hand in terms of the final decision. Although you can use the machine learning or machine algorithms in order to diagnose the problem, but again, it will be like a final decision up to the doctor. Other algorithms here, which are basically, I think you can use them for detecting forged painting. So you can use them again as well for improving these images as well. So you can see this is distorted image as it happened there. And you can feed them into the algorithm, and the algorithm can start fixing these problems on the image. And also it can detect whether that image or that painting is forged or original as well. And these are some of the applications. So here we can see that Google has used lots of images, and they fed 1,700 paintings from different artists, about 66 of them, and span of 550 years. And then the algorithm can start to learn from these data and then recognize whether that painting is real or forged eventually. So this is something which we usually cannot tell unless the person who are looking at these painting is an expert in the field, and then he can recognize what type of features on the painting in order to recognize whether it's real or forged. However, the machine can do that for us much faster, and because the machine doesn't get bored, it can do it for us repeatedly as well. So if you have a process that needs to be repeated thousands of times, of course, human, they can get bored easily, while the machine, you can throw these images at the machine for longer periods of time, and then it can do the work for you. This is another problem that people have used nowadays, and then you can see these are buildings, and one of the applications in these buildings is the heating, ventilation, and air conditioning. And depending, of course, on the type of the day or temperature outside, how many people inside the building, how many machines or how many equipment are used inside the building, and then utilization of that building. All of these basically are features which are basically used in order to design a system that can keep the ventilation and heating or air conditioning inside the building to the optimum limit in order to minimize the amount of energy used, as well as keeping the environment very comfortable inside the building. So you don't basically set the temperature to 20 degrees and then keep it running all the time. You can optimize the operation of these systems based on the type of the day, whether it's sunny, whether it's cloudy, whether utilization of the building is a lot or not. That's another problem, which is detecting speed of the cars. I think nowadays most of the insurance companies, they can put these devices in your car, and they will tell you, I'm going to reduce your insurance premium if you put this monitoring devices inside your car. Basically, they are monitoring your behavior, what you're doing, how you drive. And based on these, they they can predict your behavior, and then of course eventually if you are very erratic driver and driving very fast, they will increase your premium at the end. So this is some of the application that nowadays being used as well. More applications here, like pattern recognition, which is facial recognition, handwriting recognition, medical images as well, which are basically for cancer from the MRI images and so forth. You can generate images as well, and I think nowadays computers can draw things for you as well, and sometimes you cannot recognize it, whether it's a drawing has been generated by a machine or by a person. They can look at the credit for people, and if they have any behavior that you can basically suspect that these are fraud behaviors, they can predict that for you as well. And you can see that nowadays most of the banks, they do check that one all the time before you give you a credit or anything like that. Even on, for example, critical systems like nuclear power plants, they can monitor all the behavior or all the parameters in the plant in order to predict anything that might go wrong. Some people are using it for stock price or currency exchange rate as well. And they do work on the seconds, by the way. So they predict the price after a few seconds, and then they start selling and buying stocks or to exchange based on the seconds. And then they do make money, although it's not always guaranteed that's going to work, because most of these algorithms are trained on standard conditions. If anything happens, I think the model wouldn't be that accurate. For example, if a war breaks out somewhere in the world, or maybe a disaster happens somewhere in the world, all of these are not considered when you do these type of predictions for the stock exchange. Other applications here, web search, which we all do all the time, biology, finance, e-commerce, space, robotics, information extraction, social network as well. I think lots of these dating websites that are using these type of algorithms to match people interest, even debugging software, and of course what you do every day. Basically, I don't know what you do. Most of you, they have certain jobs, and then of course you can use machine learning on that one. So let me go into a bit of details in terms of these type of algorithms, like the linear or logistic regression, LDA, linear discriminant analysis, the neural network, naive Bayes, SVM, support vector machine, random forest, decision trees. All of these are based on supervised learning. We're not going to look at all of them, but we're going to look at examples. So this is an example of a regression model. What you do, basically, you are trying to fit a line through these data points. So you can fit a straight line, which is a linear model, or you can fit a nonlinear model to your data, and that basically predicts what happens to your data or to your system after a certain input. So for example, I can train these system based on these data, and I can eventually predict what happens in 2020, although this is nowadays, but basically this is the type of algorithm that people use in order to predict what happens in the future. The neural network, which is, as you can see here, this is a typical type of a neural network. And you can see here, if I go into some details of the neural network, you have what we call it as the input layer. So these are all the information that comes in. We have what we have here, the green dots are what we call them as the hidden layer. And the hidden layer is basically the, I think if I can get the pointer option, ink arrow visible. Now you can see that, yeah. So all these neurons in the green color are what we call them as the hidden layers, and this is the output layer, which is the purple color. So this is the input, this is the output, and what's inside is all hidden. And this is a typical neural network in the past. That's what they used to be. And as you can see, there are two hidden layers, and the training algorithm which they have used for this type of system, it was not that sophisticated at the time, so they couldn't increase these number of hidden layers. And that's what made the neural network limited to some extent at the time. But when they came to the deep learning, they have developed a new algorithms which are basically more powerful in terms of learning, and they could increase the number of these hidden layers to much more. And that's when we have this new term, which is called deep network or deep learning. So we have deep network structure, which are lots of hidden neurons inside it. A classification, that's another type of application. So here we have people with benign and we have malignant cancer. And you can see the behavior of these people, it overlaps. And we want an algorithm that basically will classify the malignant from the benign tumors. And sometimes, because they overlap, you need the algorithm to be very powerful in order to not to predict false predictions for people who have different type of cancers, as it happened there. This is more to do with the financial prediction as well, which is what we have here is depending on the type of the index here which they use, you can predict what the price of these indices as it happened there. And again, that's based on data which you provide to the network in order to learn from it. Again, this is another application, which is credit scoring. That's basically when they say you have a credit or not, when you apply for a credit card, for example, or if you apply for a loan or something. Again, they are using lots of algorithms in order to identify your credit or give you a score to your credit in order whether to decide whether to give you the money or not. Here you can see lots of data which we have from Germany, Australia, Japan, Iran, Polish data, Poland, Jordan, and the US to dollar, I think. So all of these are basically data which you can gather from lots of resources there, and then use it for training your system to predict the credit for people. Other applications here for power system, stability, control, you can diagnose fault on systems, what happens in the system, even security nowadays, which is very important because most of the systems nowadays are based on computers, and then you are basically preventing cyber attacks. So again, you can predict what happens to these type of attacks. You can forecast load. You can you can calculate the reactive power, which is basically wasted power, if you think of it, to plan for the generation. And you can estimate the state of your system as well, which is basically, I think we have a lot of that happening nowadays because of the renewable energy resources that are not easy to predict as it happens, depending on the condition of the weather. These are other algorithms for the unsupervised learning. So we have clustering, k-mean, hierarchical, and the self-organizing map. By the way, the self-organizing map is a neural network. So these are not really a neural network. This is a neural network which you use the unsupervised learning. Some of these application is the genomics. So these genomes, they generate thousands of data points from a single person. And depending on these data points, the genes, you can identify whether the patient will have, or the person will have cancer, or will have whatever certain diseases and whatever. Based on these, you can use for machine learning to look at the genes and then extract information and predict the future of the patient. Other applications here, for example, they use it on computer clustering, which is basically to send jobs to these computers. Social network as well, which are people basically how you communicate, market, and even some people use it for the astronomy as well, which are part of the applications. This is another type of algorithm, which is the unsupervised. It's called independent component analysis, and that's what it stands for here, ICA. And here what we can see two speakers. They are speaking to different microphones. There is a background noise. And what you do here, basically use this algorithm to separate the talk or the voice of each person who are talking here, and reject all the noise that comes from the background. So this is one of the algorithms that is unsupervised learning that people have used. And now it comes to the deep learning, and then this is the algorithm that basically people use nowadays, and lots of people know it as artificial intelligence. We talked about the neural network, and then we talked about the hidden layers, and then there were 2 or 3 hidden layers, and then it wasn't easy to train the network because the training algorithm wasn't that powerful. However, when they came with the new algorithm, which is for developing or learning systems with multi-layers, we are thinking about or talking about 50 hidden layers here instead of 3. You can see that the algorithm will be needed here to be very powerful in order to learn 50 hidden layers. And that's when the breakthrough came in these systems, and then they became what known as the deep learning. So what they did at the time, I think before, when they were training the system and changing the weights of the system, they wouldn't consider the changes in the weights. They are only considering the change of the error between the predicted and the actual. But they introduced a new phenomena to the system, which is to correlate the changes of the weight to the learning rate of the system as well, how the learning is happening. And that's when this breakthrough came, and they can use the deep learning. The applications of deep learning, I think most of you know the self-driving cars, and then lots of companies are working on that one nowadays. The ATM, counterfoil banknotes as well, they can reject them. Smartphones, which we know all of us now, we use smartphones with deep learning algorithms because you have it in a chip. You don't have these deep learning algorithms running on the microprocessor or microcontroller of your phone. It runs on a chip. So basically, the algorithm has its own dedicated chip that is embedded within with your phone, and that's what makes it faster nowadays. Because in the old days, everything was going to the microprocessor, but nowadays they have dedicated chips that can be used for image processing, for voice recognition, and so forth. And that way, it makes these phones very expensive. So you are buying a phone for £1,000. If you remember, in the old days, we used to buy a phone for £100 by most, the Nokia. But nowadays, the iPhone is very expensive. It's all because of these technologies which are embedded within the phone itself. So these are some of the applications. I think this is image recognition for one of the applications for deep learning. So you can see that the algorithm can look at a very specific areas in the image here, and it can learn from these areas instead of looking at the whole image as it happened there. And that's one of the things that is one of the features of the deep learning as it happened there. So why does it become the state of the art? It becomes the state of the art because it can deal with very complicated problems. It's all because of the processing power. So you have the processing power nowadays, and most of the days people are using GPUs, which are the graphical processing unit, which are very fast. In the old days, they used them for on the game consoles for displaying images on the screen. But they are very fast processors. They are unlike the normal microprocessor. They are very fast in terms of crunching numbers, and that's what we need for the deep learning. So we don't have to worry about other peripherals on the computer, a keyboard, monitor, whatever. All what happens inside the GPU is basically number crunching. And that's one of the features of the deep learning systems, that they can mostly learn on GPUs to make it faster. And there is a very big difference between training a system on a microprocessor and on a GPU. I think maybe 10 times fold or something in terms of the speed. And as you can see here, these are a typical. This is a typical network that we have here. I don't know why I have lost the. Here we go. This is a typical network that we have, which we use lots of layers of the network in order to make it learn from multi layers as it happened there. So although this is a typical neural network, but as you increase the number of hidden layers, that's what makes it as a deep learning. You can include as many inputs as you like, as many outputs as you like, but however, the most important thing is the hidden layer and the type of the network as well. So we'll see that it's not only supervised, there are other type of networks inside it as well there. So how does it learn? So the system learns by looking at the input data into different stages. So for example, if we want to recognize a flower here, for example, this flower, we're going to feed this image to the computer, deep learning, and then the computer will start extracting features from the image in order to learn what type of image is that, or what type of flower, let's think of it. So it will subdivide the image into very small segments, and then it will recognize features on these segments, and then it will move to the next layer or the next stage of the learning, which is basically to combine these small segments into a bigger segment and carry on with these until you get the whole image. So you are basically subdividing the image into small pieces and then start building up these small pieces into bigger pieces. And let's think of it. For example, if I look at a person's face, you can look at certain phenomena on the eye, for example. You can look at the nose and so forth. But once you put all these together, you can recognize a person. You can recognize certain objects on the face, eyes, nose, mouth, and whatever, but you cannot recognize a person out of these small features. But once you put them all together, you can end up with a person face or a person image, as it happened there. And this is a typical diagram of a neural network. As you can see here, this is an image, and then it's taking small pieces of the image, put them into a layer of the neural network, and then combine these into another layer, combine these into another layer, and you move on through these layers as it happened, which are the hidden layers, if you think of it. And all of that, if you think of that, we mentioned the supervised and unsupervised. This is all unsupervised learning as it happened. Once you do all of that and then you extract all the features, you move to another stage, which is basically, you can see here it says classification. And if you remember, classification was based on the supervised learning, not on the unsupervised learning. So I can combine two types of networks, unsupervised, which are basically extracting features, and supervised, which are basically classifying. So eventually I can classify what type of car is that by using pieces of the image and then taking the features of these image and put them into a classifier, and the classifier will tell you that this car is type of X or Y. By doing that, basically you have a very big network, and that's what we note as deep learning. And then you have to have different stages of training. So you have to do the first stage here. Once you extract the features, you take the features and feed them to another stage of the neural network in order to learn as a classifier. It doesn't have to be a classifier, it could be a regression as well. So here, all the features are taken from the image, and then eventually you tell that these features which you have extracted from the image, it belongs to a car, or it belongs to a truck or a bicycle, and so forth. Once we train the system, eventually we can feed any image to the system, and it will tell us that this is a car, or this is a bicycle, or a truck, or whatever. So this is the way the network works as it happened there after training. So how the network learns, usually we present it with all these images, and it has to train with all these images step by step, and that takes a long time in order to make it learn from these images. So you can, although nowadays I've seen networks that they can recognize type of sports by just presenting videos to it, and it will work based on the data that it has learned from. So let's look at some of the applications here. We did mention the autonomous cars, and as you can see here, this is the Google car, I think. I don't think it's Google, somebody else. No, that's somebody else's car. It's a Prius, of course, as it happened. And as you can see, there are lots of instruments on the car. For example, the LiDAR on the top, cameras, lots of sensors as it happened on the car there, in order to GPS as well, of course. All of these are used in order to make the car drive on its own. So it's not a single sensor, it's a multi-system sensors, multi-systems, lots of systems that work together in order to drive the car. And if you think of it, I have to process all these informations in order to get to the to the way to drive the car. So here we can see the LiDAR, which is basically to scan the area in front of you, the GPS, the another radar here for obstacle detection, and the cameras as well, which are inside the car. All of these are different systems. So each system is going to need its own processing of the information that it can generate. It does generate, and eventually you combine them together in order to drive the car. This is only for finding the way in the front of the car. This is not for driving the car. So if you want to drive the car, you need to learn how to drive the car as well. So this is another system if you think of it. So by doing these, I just explored the area in front of the car. However, if I want to drive the car, I need to use the GPS so I know where I'm going. I need to teach how to drive the car. So what they have done here is they have generated data from two people who are driving the car during a certain road. So this is Sebastian and Stanley. So they gather their behavior, pressing the brake, pressing the accelerator, steering, and so forth. And based on, well, of course, with respect to the GPS data, and based on these, they analyze the behavior, and then they train the network in order to drive the car. Of course, you can see that different behaviors for different people. So the more people you got as data to train the system, the better in order to drive the car. This is a typical image of the system on the car, which is basically to analyze the what it captures. So for example, this is an image from the cameras, and our aim is to detect the objects in front of the car. Remember that we use the deep learning in order to recognize cars. So this is the actual image, and this is the what the computer sees. So it will see that this is a car, this is a car, this is building, this is a road, and so forth. So that's the way the system is processing the data in order to prepare the system for driving the car and for finding the way, of course. This is not the only application. So we've seen other applications like Google are using it for marketing, and Bloomberg are using it for, I don't know, trading and so forth. You have seen lots of robots are using deep learning. Lots of computers as well. It's a lot on the news. So this is the CNBC, which are basically they are talking about deep learning. It doesn't happen in the States, of course. It happens everywhere as well, which is one of the things that one of the features of the deep learning. So a typical example of convolution and neural network for recognition of a face of a person. So here, what we can see, we can look at the different features on the image, and then combine these features into more bigger objects. And you can see here we combined for the eyes, and then combined for the nose, for the ear, and so forth. And eventually you put these together and recognize people as well. So in each layer here, you can see you start from the pixelated image. You go to the different features of the face, which are very small features. You go to more like an organ, a nose or an eye or whatever, and then you move on in the steps until you get to the face of the person. And based on that, you can recognize that person, whether it's an X or Y person. It's not only face recognition, so these are for faces. These are for cars. This is for animals, and this one is for objects like chairs here. So you can see the lower level here, more or less, it's very similar. But once you progress through the image, and you can recognize shapes. And this is what we do, by the way, as a human. That's how we recognize people. So we look at the person from a distance, and then we go and recognize on the face, recognize on the shape of the maybe clothing or whatever, and then eventually you can recognize a person from these features. It can also use for detecting or recognizing people with blurred images or half-masked images. And I think nowadays, because most of us are wearing masks outside the house, this is one of the applications that people can use in order to recognize people with suspected people with wearing masks as well, which is one of the applications that can be used in the future. This is another application for speech recognition. You can see as well, it extracted features, it feed it to a neural network, it decode that, and then eventually it will come out with what you're saying. And this is the system that we have on our phones to understand what we are saying to the phone or talking to the phone. Other applications, of course, and I think you've seen these nowadays a lot. Google is very frontier in terms of doing this technology. I think lots of phone companies are using these as well. game consoles as well, which are used there. I think this is Siri, and I can't remember what that stands for, but it's another technology that is being used by one of the companies, which is on the phone as well, of course. If we go into other applications using AI nowadays, telemarketing, bookkeeping, compensation managers, receptionists, career, proofreaders, even nowadays they can read your text and they can tell you that this is not right in terms of the linguistic. Market research analysis, advertising, retail salespeople. These are areas that is not being explored fully. So resource management, sale managers, marketing, although nowadays I think people are using them nowadays as well. Executive people, planners, writers, although I think computers can write stories nowadays as well. Software developers, editors, graphic designers, all of these are a new application that people will be using in the future. And this is in one of the news that one of the Japanese companies, insurance companies, they have replaced 34 staff with an AI system so they can detect the claimant claims, whether they are fraudulent or they are genuine, using an AI instead of people. So basically they laid out 34 people and replaced them by a computer. And this is one of the things that we should worry about. Eventually, are we going to be kicked out of our jobs and then will be replaced by computers? So there are lots of things in terms of the AI, and this is something that lots of people, they need to think of in terms of the ethics, the accountability. So I think one of the events that happened to the Google car, I think it made an accident. Who's accountable for that accident? Is it the AI? The AI is a machine. It's a computer. I cannot go and prosecute a computer in the court. The principles behind it, integrity, the values, all of these, I think people are working on these nowadays because there are no regulations for these. That's the problem. The sector is not regulated yet, and you know that I think Facebook or YouTube or whatever, they have lots of ethical issues in terms of using these type of technologies nowadays, and then people are developing these laws and regulations as they go along with the problems that they are facing day by day. I think you can recognize this person, Captain James T. Kirk, and if you are a fan of Deep Space or Star Trek, this is introduced in the 1973, which was, I don't know how much, 50 years ago, if you think of it. More than, yeah, about 50 years ago. And you can see that he had this more like a walkie-talkie or a machine that he can talk to. And he can talk to the ship somewhere in the space, and they can beam him up and so forth. So this was more like a fantasy, not fantasy, or science fiction as it happened there before. And that was, if you were at the time and you were watching these videos or these films, you would say that's fiction, that's not going to happen. However, it's happening nowadays. You can talk to your watch. You can talk to yourself, and I've seen lots of people, not now of course, because most of the people are staying at home. I can see lots of people talking to themselves on the street, and you think, is he talking to me or not? No, he's not talking to you, he's talking to his phone, and his phone is basically embedded into his ears. And nowadays I think they are even developing glasses that the phone is embedded into the glasses itself. So basically you are talking and listening to the glasses, basically on an earphone on the glasses that you have. So this is happening. Remember, that's 50 years ago. Now it's happening. Again, this is another film, The Terminator, if you watched this film before. So now we have machines that basically controls the Earth. Again, this is fiction. This is not when they introduced the film at the time. Arnold Schwarzenegger, he was the Terminator at the time. And you think of it, maybe it doesn't happen. But if you look at Asimo, it's a robot. It can walk. It can do what we do, basically. And if you give it the power with lots of machine learning algorithms or lots of processing power, eventually start to think, and then it will make its own decision as it happens. And you can see lots of these machines are being developed nowadays. And that's why I was referring to the ethics, to the accountability, to the other features that we are thinking of nowadays, which we don't think of it nowadays. We just want to develop algorithms. We want to develop applications without thinking whether these will be eventually be taken over in the future or not. And if I go back to this slide, that happened 50 years ago, and it's a reality now. So who knows, this one might happen. And as you know, this is happening very fast. So 50 years ago, it happened to be, now we can use that, but maybe in 10 years' time, you might see robots walking around. And I'll leave you with this thought as it happened there. And I think within our group, within the center, there are lots of people who are working with the ethics and then with the development of these systems. So this is something which we should be researching as well. I think this is the last slide, and I will stop here. And I know there are lots of comments on the chat, which I didn't look at, by the way. And I think it's blurred for some reason. I cannot read them on my screen. But if you have any questions, please do let me know. We can discuss things. Yeah. Tatiana is talking about plumbers, so we're going to have.
Thank you, Maysam. There's been some very interesting discussion in the chat box here. Fortunately, Akram has been dealing with some of the more technical issues, like what changes in a model, what is explainable in AI, and so on.
Yeah. I did mention at the beginning, you're not going to be an expert after this talk. No.
And then there's a discussion about the job losses. Again, super interesting. It's been a really clear presentation. I wonder if some people had to leave in the meantime. Yes. I wonder if people have more questions. I have one for you while people type.
Please go ahead. Yeah.
You gave lots of examples of how technology is being used everywhere. And then you said it will impact what you do. But it's funny that you didn't really give many examples of AI or machine learning being used in education. And I wonder if you could share some examples or no.
Well, I haven't seen any machine learning teachers still, but there might be there anyway. So soon we will be replaced as well. Yeah, I think it's possible. You can develop algorithms for looking at the behavior of the students, and of course, based on what they are doing, you can repeat things for them and try to basically motivate them or keep them engaged with the lectures. But as far as I I haven't. Although I'm not really in the topic as it happened to search for machine learning algorithms for teaching, but there must be some, definitely.
Yeah. I saw a discussion of one where they would do marking, machine learning. They would mark assignments, and then somebody realized that if you used longer words, you would get a better grade.
That's a nice one.
But anyway, Tatiana wants to say something.
I just wanted to mention about AI and education. It has been happening several things. Like, for example, you mentioned about marking, like sort of longer words is better marks. It's definitely my work. But as far as I know, there are already several educational games, gamification and education that has been used for primary children, where AI has been used to determine the level of the children and the next tasks. Some of them do exist and they use quite effectively. I would say that the learning curve for the children, they not always challenge the children to the level, but I think it's already a good start. And I can give you several examples, like Prodigy game in maths for the primary children. It is designed using some AI for identification of trajectory for learning for the children, for example. But at the same time, plagiarism checks and anything, it's another examples of AI which we actively use when we are marking and looking at our assignments of our students.
Yeah, thank you. Any other questions that we can discuss? Or I know I took longer than expected because I'm supposed to finish by 5 o'clock. It's 1/4 past the hour now.
We had quite a bit of interesting discussion going on in the...
Yeah, I can see lots of discussions happening there, which is interesting and stimulating as well.
You have a question from Neil saying, do you think AI can ask genuine questions?
That's a good one. I think Tatiana did the presentation when we were able to go to the theater. And at the time, I think she presented a few images as it happened, or painting, and then she was asking, can you recognize which one is generated by a computer, which one is generated by a person? And it wasn't easy to recognize these, by the way. If you want to say something, Tatiana, on that.
Well, I can tell you it's quite interesting the way how this presentation goes, because I have we created a system which created some paintings by ourselves in 2003, and quite for a long time I was using this presentation running through audience, and audience literally never has guessed who has done what. So basically it was always the wrong guesses what AI has done and what hasn't been. But I'm surprised in the last year or so, as in become a more general acceptance of AI, I'm getting more correct answers on this slide. So if I can find this picture, I can share with you, and we can have a look how people will react to this presentation.
I'll stop sharing then, so you can.
Give me a second. I need to find this, and you could keep talking until I will find.
Yeah. I think nowadays, I think maybe you've seen lots of videos nowadays. People are talking, but they are not the real people. They are basically generated by computer. So what they have done, they have basically learned their behavior, the way they talk, and then started to make the computer talk on their behalf and do whatever they want them to say, basically. So this is happening as well, and lots of people, I think they are more familiar with that system nowadays and that type of system. So again, I think this is something which is being developed by lots of companies, and of course most of these systems are always being developed, so it's always something that is happening in the future, or something that will happen in the future, that more algorithms are coming through. And the field is very dynamic, lots of things happening all the time, so it doesn't go like a few months and then you find a new algorithm in the market or in the research community talking about maybe, I don't know, better presentation or better. Okay, so Tatiana is ready to quiz us on these type of images. So we have 4 images.
Okay, we have 4 images. I think everyone should see the 4 images, and it could be interesting to see. So if everyone in the chat put which image do you think has been generated by AI? So let's have a look and see what will be like. Who thinks what of image has been generated by AI? I can tell you this image has been generated in 2003, so it was 1.5 decades ago to start for you. So this is how far we can now go ahead and see. So let's see how the people are responding.
Oh, it's quite varied.
Yeah, they are not exactly the same image.
So we have top left, 2 bottom lefts, 1 top right.
Yeah.
These are the votes so far. Any bottom left, another one?
Of course, they are not traditional images as it happened.
It's abstract one, and it was the aim on. So let's have a look.
Another vote for top right, top left. So we are nobody for bottom right. No, everybody's going for the other 3. Akram said, now we're learning from the audience too. Yes.
Nice one, Akram.
interesting because I think we are getting a bit of variation of results today. So I think it's more younger generation. When I was presenting to the children like sort of were very quickly were spot on, which was generated by AI.
Yeah, that's the computer generation.
I think
yeah, it's computer generation children. Yeah.
We have quite a few lower left, and then top left and bottom and top right. So what is the solution?
So what will be the answer? The answer is the top right. It's a painting, oil painting by the Mandrill by Frank Marz. Bottom right, it's aquarelle painting, and it's by Rectapopoulos from the internet. Bottom left, it's fractals. It's basically mathematical algorithms which describe equations and so on. So basically fractals. And the image which you see, top left, so you could feel the winner, the one who said top left. This is the image which we have generated by our system.
That's the least you would expect that is generated by a computer.
Yes. And this is the image which has been generated by a computer for you to start. And this was done in 2003. So it's when graphics and not a lot of images has been done. And fractals is AI, but it's mathematical AI. Fractals is repetition of patterns, is not really exploration of creativity, isn't it, Akram?
Yeah, fractals was there in the 80s, I believe. So
yeah, fractals is mathematical descriptions of representation which will be present. So basically it doesn't use exploration of creativity and exploration of new patterns and discovery of new patterns coming around.
Yeah, it goes into more details if you dive into it.
Yeah, so you could really see like sort of this type of pictures. We can have a look on what we get. And I think like everyone who is working in AI, I think what you need to remember, don't be disappointed when you start to work with AI and you're not getting results. You don't get results immediately. So you see the images we get. I will show you where we're getting from. At the beginning, this is what type of scattered images we were getting. So not nearby that you could appreciate and say, well, yeah, it's something, it's good. Yeah. So it's not really about like sort of what you get. You really need, like, in order to become an AI expert, it's like getting some experiences we can get. Original results which we get, you will say, no way you could get even nearby, but we get. And I think at some point I did get the artist and look at the pictures. You see these 3 pictures? It's all pictures has been generated by our art AI-based system.
Yeah.
So all these images have been generated, and at the time what we did, we asked the artist what they think about these pictures, and what we did say, we didn't say that machine was done it, because it was 2003, and if I'll tell them that machine was done, it will just not even provide me any feedback. They'll say it's rubbish out. And I tell them that I know the artist who has basically did some work, and they just produced some images and would like to get some feedback from you. What do you think about images, the pictures that has been produced, and do you think it's worth of anything, and does it basically cause on anything? So basically I did show this for professional artists, this type of pictures. What do you think the result was? Anyone?
Mostly they think it's an artist's work rather than a computer work.
Yeah, I thought it was the artist's work, and I'll show you some feedback. I don't know if you see that it's written up, might be quite images. Some of them we were comparing some pictures to Van Gogh, so imitations of a style of Van Gogh. Some of them were looking on some inspirations was taken from leafy forest, ice skating. Okay, so they didn't even consider that these images have been generated by AI. You could imagine the face of all these artists when I told them that it's done by AI. They haven't spoke to me for a month before they start to talk to me again.
Was it scary AI or what?
It was scary, but remember, we speak about 2003.
2003,
it was no general acceptance of AI. So now when we say that AI can do this, and say, yeah, what's about? It's normal. Yeah. So, but reaction like 1.5 decades ago will be like, you cannot show me this, you cannot say this, it's impossible, and so on. So basically, no, we eventually start to speak again, but reaction was quite interesting. So
yeah, that's one of the things that how people will receive it, whether they would accept it or not. It's not straightforward, isn't it?
Exactly, but nowadays the society does accept more AI, and we are doing now. There is major acceptance.
Yeah, it's in the news everywhere. It's in the news. Whenever you watch the news, we're going to use AI, and people, they don't know what exactly AI, what type of AI they're going to use, but it's in general term AI, and that's it. Okay, I think we took longer than expected as it happened there. It's 25 past the hour, which is, thank you very much for everybody for attending this, and hopefully we can carry on with these type of seminars as it happened. These are internal seminars as it happened. These are not, we are not inviting people from outside, and we will have another 3 lined up. I think we'll talk about the ethical issues. Tatiana will talk about her experience with developing a system for the one of the companies, Caterpillar. And then we have another one, which is all basically being scheduled on, if you look at the schedules on the teams, you'll have these lined up as it happened there. So yeah, without further comments, I think.
Maysam, we have a question from Mohammed. He was asking about optimization, algorithm for optimization using NN. If you speak about optimization, I would not go for neural network for optimization problems.
Yeah, I didn't talk about optimization at all. It's mostly different algorithms. Again, they are classified under AI now. So, for example, genetic, which is one of the algorithms, the swarm intelligence nowadays, or they call them biologically inspired systems. And this is one of the systems that people are using nowadays, and they are powerful, as it happened. Much in comparison to the traditional techniques, they do produce better results, of course. But this is something which I really didn't mention today at all in terms of the optimization. So people are still using these techniques. I think that's what you're going to talk about, Tatiana, aren't you? Which is in your talk. And,
yes.
And that will be was it in April, I believe, isn't it? Sometime.
Yes, we will be speaking more about optimization for this type of case study because we were using this. But remember that whenever you speak AI, the secret is there is no algorithm which is fit for everything, and it's never will be. Okay, so you need to make sure that it's basically you use the correct algorithm for correct problem solving.
Yeah, yeah. That's a very good conclusion. Nothing fits all. So when you hear AI, that doesn't mean AI fits everything. So it's a very big field and lots of algorithms available. And we'll see the details hopefully when time comes. Okay, thank you very much, everybody. And hopefully you have a nice evening and stay safe with these conditions that we are living in nowadays. Hopefully the AI will solve it. I don't know if it can, but we'll see. Good evening, everybody.
Good evening. Bye. Thank you, Maysam, for organizing this.
Thank you. Bye.
Thank you. Bye. Thank you.